Welcome to this talk on CHAS-SIS, Conformity Meets Online Information Diffusion. This is a joint research with Hui and Surav from NTU Singapore and Hui from Xidan University in China. Let us begin with the notion of online information diffusion. Information diffusion is the process by which information and ideas spread over a network, creating an information cascade. In social networks, this process will typically generate a large volume of social activities such as posts, tweets, shares, likes and comments. Information diffusion underpins several applications in the real world. For example, it is the foundation for the influence maximization problem, viral marketing, rumor detections, as well as user behavior prediction. Let us take a look at how models for the information diffusion process are typically created. Consider a timeline of social activities. We can observe the social data over say time t. Then an information diffusion model is built from the observed data. Once the model is built, one can use to make predictions beyond time t. So what kind of predictions can be made? For example, we can answer the following kind of questions. What will be the size of the information cascade? Who will issue the next activity and when? In summary, information diffusion models are invaluable for answering various kind of questions that enables us to comprehend information propagation. The key contribution of our paper is a novel, data-driven online information diffusion model called CHAS-SIS. In this talk, we give a brief overview of CHAS-SIS. Interested viewers may peruse the full paper. Quality of any information diffusion model depends on how accurately it can explain real-world data. So how good is our model with respect to the state of the art? To answer this question, we studied the performance of our model using real-world data from Facebook and Twitter. We compared CHAS-SIS with state-of-the-art online information diffusion models. This particular slide shows one of the key results. The x-axis represents the percentage of data used for training. The y-axis shows the log likelihood values, which basically quantifies the quality of the model. As you can see, that more training data leads to better accuracy for all the models. The more important observation is the performance of CHAS-SIS. It significantly outperforms all the state-of-the-art online information diffusion models. In other words, CHAS-SIS captures the information diffusion better than existing techniques. This naturally leads to the following question: what is the secret behind CHAS-SIS success? The answer to this question lies in the happy marriage between social analytics and social psychology. In particular, we marry online information diffusion models with the notion of conformity, which is a well-known theory in social psychology. Specifically, conformity is defined as inclination to align our attitudes and behaviors with those around us. It is a well-studied concept in social psychology and there has been extensive research in this area. Let us first highlight how conformity plays out during information diffusion. Let us consider this particular social network, which highlights a set of users and their follower-following relationships. Now let's assume after virtual SIGMOD 2020 there is a burst of social activities in the social network among these users. Let's say U4 triggers a discussion by posting that virtual SIGMOD conference was great. And then, U5 responded to it by commenting, "I really like it." After that, U1 agrees with U4 that probably this is the best SIGMOD ever. U3, a friend of U5, also agreed with U5 that it was really a great conference. However, U2 asserted that it may not be as good as the physical SIGMOD conference held in other years. And finally, U7 agreed with U1 that it was a very interesting conference. Now, let's focus on U3. U3 responded that it's a great conference. This may be due to two possible reasons. Let's consider the first one. U3 may not have attended the virtual SIGMOD at all. However, U3 trusts the opinion of his friend U5 and agrees with him. On the other hand, let's consider the case that U3 has attended the conference, but, similar to U2, really didn't like it. However, since everybody else said it's great, he simply conforms to others and commented that it's a great conference. The former is called informational conformity in social psychology theory. Specifically, people conform to peer views in order to reach an appropriate behavior or attitude because they don't have the knowledge about a particular concept or event. For example, in this case, U3 does not have the knowledge of virtual SIGMOD conference. So he conformed to his peers' view. The latter one is called normative conformity. It is displayed when a user desires to be accepted by others. For example, although U3 does not like the virtual SIGMOD, but because everybody likes it, he agrees with others, displaying normative conformity. Now, how does such conformity behavior influence information diffusion models? If you consider popular information diffusion models such as independent cascade model or linear threshold model, these models typically compute the influence probability based on topological structure of the social network. These models are all conformity unaware. For instance, consider the independent cascade model. According to this diffusion model, U5 will activate each of its outgoing neighbors with an influence probability which is often set to be inversely proportional to the in-degree of a neighbor. Consequently, U2 has a higher chance to be activated compared to U3. However, if you take conformity of these two individuals into consideration, it is clear that U3 is more conforming to U5 compared to U2. U2 simply didn't agree with the view of U5. So it is more likely that U5 will activate U3 instead of U2. In other words, it is paramount to include conformity of individuals while modeling information diffusion. However, this is challenging to undertake as detailed in the paper. We briefly summarize these challenges. First, the private beliefs of individuals may not be exposed explicitly in the social activities. For instance, U3 may not explicitly mention in her post that she wants to please her friends or have not attended SIGMOD. Hence, it may not be possible to determine whether an individual is conforming to another by simply searching for one's beliefs in the posts. Second, conformity of an individual may vary with the context. One may show high degree of conformity for one topic of discussion such as conferences but not another such as politics. Hence, any conformity computation technique needs to be context sensitive. Third, the knowledge of topology of a social network is insufficient to address this problem as connectivity between individuals do not necessarily indicate manifestation of social activities among them. For instance, some followers may rarely or never interact with some of their follows, and some individuals may respond to some other unconnected individuals in online discussions. Our proposed solution addresses all these challenges. The novel contributions of this work are as follows. Since social activities represent asynchronous timestamp sequences, we deploy a well-known statistical technique called Hawkes process, which is a type of point process that has been utilized recently to model information diffusion. In this work, we extend Hawkes processes with the notion of conformity. Specifically, we incorporate informational and normative conformity in this model. The second contribution we make is we devise a novel data-driven technique that is grounded on social psychology theories, to quantify conformity by analyzing historical social activity sequences. Third, we present an efficient, semi-parametric inference approach to learn the conformity-aware information diffusion model from the observed data. Specifically, the parametric evaluation procedure assists in identifying conformity of individuals, and the non-parametric procedure learns the triggering kernel functions flexibly in a data-driven way without the need of prior domain knowledge. Extensive experiments with real-world datasets show superior performance of ChasSys in modeling information diffusion compared to several state-of-the-art conformity oblivious techniques. ChasSys can be utilized to predict individuals' future behavior with considerable confidence, illustrating the powerful effects of an individual's inclination to align one's attitudes and behaviors with others. Please peruse our paper to get details about these three contributions. We now give an overview of our approach. First, we utilize the branching structure, an equivalent representation of Hawkes processes, to represent the social activity sequences. It allows us to isolate the events or activities in our context, in a Hawk's process into immigrants and offsprings. Immigrants are events that arrive independently, whereas offsprings are events triggered by existing events. Then we utilize the parent-child pairs of events or activities in the branching structure to quantify the two types of conformity. Finally, we use them in our model. Specifically, our semi-parametric approach learns the model components from observed data as well as infer the branching structure in an alternating fashion, which is an instance of the expectation maximization method. To conclude, this is the first work that models information diffusion by incorporating concepts from social psychology theories. This is a multidisciplinary effort where we make online information diffusion model to be conformity aware. A broader goal of this work is to stimulate a cultural shift in our thinking by infusing cold hard social analytics techniques with theories from social psychology. Note that most of existing social analytics techniques do not consider theories from social psychology. We wrap up our talk with a lighter note. These are unprecedented times. Even now, we can observe conformity at play. One may not like to wear masks, but since everyone else is wearing masks, one chooses to do so as well. That's all from us. Thank you.